Hi guys, it's Mrs. Seitz, and today you're going to be learning about some properties with exponents when you divide. So for example, if you take a look at our first activity, we're going to actually see what happens whenever we have multiple copies of a base whenever we're dividing. So for example, if we look at the first problem, we have 4 to the third power over 4 to the second power. So if I write out 4 times 4 times 4, or 3 copies of 4, over 4 to the second power, 2 copies of 4. What I can start doing is start crossing out some pairs of 4, meaning 4 divided by 4 is 1. I'm going to start crossing out my pairs of 1s. So 4 divided by 4 is 1 again. How many do I have left over? I would just have 1 4 left over, or 4 to the first power. I'm going to do that again. Look at the next one. I have 6 copies of x. And I'm going to put that over 3 copies of x. And again, if I crossed out my 1s, here's a 1, here's a 1. How many do I have left over? I have 3 copies of x left over, or x to the third. So that means if I had x to the 6 divided by x to the third, I would end up with x to the third as my answer. Let's see if you can start making a prediction. If I had 2 to the 5th power, or 5 copies of 2, divided by 2 copies of 2, could you start to even make a prediction of what our answer would be? If you were starting to guess 2 copies or 3 copies of 2, you were correct. Because look what's happening. If I cross these out, how many are left over? There's 3 copies. Did you notice that there might be a trick right here, though, with our exponents too? Watch right here. See if you can make that prediction. If you have 4 copies of 3 divided by 4 copies of 3, what's going to happen to all these copies? They're going to cancel each other out, right? So how many copies of 3 do you have left over? None, right? So your answer would be 1, because we know that 3 to the 0 power is just 1. But for our sake, just look at the exponent. What are you doing with the exponent? 4 minus 4 is 0. 5 minus 2, 3 in problem number 3. 6 minus 3, 3 for our answer for our exponent. So that means that any time when you have the same base and you are dividing, the exponents are subtracted. So let's go ahead and let's see what that actually is. Okay, so if you look right underneath here, to divide powers having the same base, you would subtract your exponents. So if you had a to the m divided by a to the n, you would keep the base of a and you would subtract in order from numerator to denominator m minus n. So for example, if you have 7 to the 6th divided by 7 to the 4th, you keep the base of 7 and you subtract in order 6 minus 4 to get a power of 2 on 7. So let's take a look at these 3 examples together. Keep the base of 6, subtract in order 5 minus 4, and we're going to end up with 6 to the power of 1, which we can simplify that down to 6. If I look at my numerator, I have 9 to the 4th power and 9 to the 2nd power, and we're dividing that by 9 to the 7th power. If I look at my rules from before, I know that I would have a total of 9 to the 6th power, right? Because I would keep my base and add my exponents, over 9 to the 7th power. So the rule says keep my base, subtract my exponents. So 6 minus 7 is going to give me negative 1. I learned from yesterday or from the day before that in order to fix that negative exponent, I need to put that over 1 or take the reciprocal to flip it and make that into a positive exponent. So that becomes 1 over 9 to the first power, which would become 1/9 for your answer for the second one. And then for the last one, it's a little bit more complex, but if we follow our rules, we'll be fine. We're going to match up the variables first. So I see x to the fifth over x to the second. So x to the fifth minus x to the second, that's going to give me x to the third, y to the eighth, and y to the 10th. So in order, 8 minus 10 will give me -2. And then let's look at the fraction part. If you cover up the actual variables in the problem, you can see that you have the fraction 2 over 6. So again, if you go to your calculator and you type in 2/6 as a fraction and simplify it, you're going to get 1/3. So again, I'm going to transfer 1/3 into my answer. All right, and I want my final answer to look like a nice fraction. Okay, and I'm going to bring these variables back into the problem. So I'm going to get rid of that part that I marked up. Okay, here's what I'm going to do. I'm going to put a 1 underneath this, and I'm going to put a 1 underneath this because I know that I'm going to need to do the reciprocal on that y because it has a negative exponent. I don't need to do anything with the 1/3, and I don't need to do anything with that x to the third because they have positive exponents. So I'm going to transfer over the 1/3. I'm going to transfer over that x to the third over 1. And I need to fix right now that y to the -2 and move it down to the denominator because it has a negative exponent. So I'm going to flip it. Okay, my last step is I need to multiply straight across. So 1 times x to the third times 1 is just going to give me x to the third because anything times 1 will give me itself. So x to the third. The bottom, well, 3 times 1 is 3, and then times y to the second will give me 3y to the second. And there's my final answer. And again, all I did was just multiply straight across in both the numerator and denominator to get my final answer. All right, let's try one more that's like that. Okay, so again, I'm going to group the things that are the same. I'm going to save the number part for the end. So I have right now a, and then I have 15 minus 14. So that's going to give me a to the first power. Then I'm going to group the b's together. 20 minus 18, which is going to give me b to the second. And then for the c's, I technically have a power of 1 sitting here. So this would be 1 minus 2. So that would give me c to the -1. And then don't forget, you technically have 8 over 4 in the front. So remember, 8 over 4 will give you 2. Okay, now what we're going to do is we're going to put this together with 1's underneath, and we're only going to move things that have negative exponents. So the only thing that has a negative exponent in this problem is the c. So I'm going to rewrite the 2. I'm going to rewrite the a. I don't really need to write that power of 1 there because anything raised to the first power is just itself. But I'm going to flip that last part to fix it. And I'm going to put with a positive 1. Okay, remember the last step is you're going to multiply straight across to get your answer. So 2 times a is 2a times b to the second times 1 is just going to give me 2ab to the second. And then the last part, 1 times 1 times 1 times c to the first, is just going to give me c. So the final answer for that one, guys, is 2ab to the second over c. And the little rule I have for you guys is to make sure you simplify the numbers in the number bases as fractions in the end. So that's just reminding you, like the 8/4 in this problem, make sure you simplify it, and make sure you always simplify like that 2/6 as well. Another a little thing that people that get a little bit confused about sometimes too is how do you know where you end up with some of your variables? And a little trick is, like if you look at this problem that we just did, this 2x to the fifth, y to the eighth, and then 6x to the second, y to the 10th, we knew that that y to the 10th had to have the final answer in the bottom, because if you look, the larger power kind of tells you where your final answer is going to end up. So y to the 10th is bigger than y to the 8th, so our final answer has to end up down there. Just like if you would put the x's together, or if you see in this problem, the x here, x to the fifth is bigger than x to the second, so we ended up with our x answer in the numerator. If you look at the problem we just finished, a to the 15th is bigger than a to the 14th, so the a ended up in the numerator. Same deal with the b's. The 20 is bigger than the 18, so the b ended up in the numerator. And with the c's, the c of the second is bigger than c to the first, so the c ended up in the denominator. So it's a little trick to kind of help you out to determine where your placement would be. All right, another rule that we're going to have is if you have parentheses. So for this one, it's telling you how many copies that you would have of each. So if you had, for example, 2/3, and I had 2 copies of it, that means I would have a total of 2 copies of 2 and 3 copies of 2. If I had x over 2 3 times, that means you would have x to the third over 2 to the third. I don't think we need to multiply out every single one of these to figure out what the rule is. Basically what you're doing is you're taking the exponent that's on the outside of the set of parentheses and you're distributing it to both the numerator and the denominator. So the x got the power of 3, the 2 got the power of 3. If I actually multiplied out 4/3, 4/3, 4/3 3 times, you would get 4 to the 3rd over 3 to the 3rd. And this one here, to make your prediction, you would have a to the 4th over b to the 4th if you actually multiplied that out and would count up to see what's happening. So in terms of a general rule of what's happening here for a power of a quotient, what you're doing is to find a power of a quotient, you are basically finding the power of the numerator and the power of the denominator, and then dividing like you would before. So for example, if you had the quantity of a over b to the m, you would take that exponent of m to both the numerator a and the denominator b. So that would be a to the m over b to the m, provided that b is not equal to 0. And so if you had an example like 3 to the 3rd, or 3/4 raised to the 3rd, we'd have that 3 to the 3rd, and then raise 4 to the 3rd. And then simplify those down further. Okay, we can always distribute exponents over multiplication and division, and that's been the theme throughout this whole entire lesson. But you can never, ever, ever distribute them over addition or subtraction, okay? And that's really, really important. So make sure you put some big stars there, because there will be some tricks in the future. If you ever see a plus sign in a problem or a subtraction sign in a problem, remember that that might be a trick, okay? Remember, multiplication and division are how these rules work. All right, so let's try a couple of these problems out. So using our shortcuts, if you have a set of parentheses and you're raising an exponent to both the numerator and denominator, we have 2 to the second over 3 to the second power. This time we're actually going to simplify them out. So 2 copies of 2 would be 4, And 2 copies of 3 would be 9. And you always want to check to see if that simplifies down further on your calculator. But I know that 4/9 will be completely simplified. All right, now this next one's a little bit more complex, but you need to remember that you're taking each factor inside the numerator and denominator to that exponent. So we'd be doing 2 to the 4th power, x to the 4th power, and then we're taking that whole denominator to that power 2. So it would be y to the 2nd power raised to the 4th power. All right, so to start simplifying some things, okay, 2 to the 4th power is 16. Going to keep the x to the 4th. Now, if you have 2 exponents in a row, or a power of a power, you would be multiplying those together. So that would be y to the 8th power. So your final answer for the second example would be 16x to the 4th over y to the 8th power. Okay, and then the last example here, I always assign the negative to the numerator. So I would actually rewrite this problem before I start distributing so I don't make a sign mistake. And I'm going to make this, and always protect the negative numbers with a set of parentheses. This would be the quantity of -3 raised to the -3rd, and then y to the -3rd. Okay, before you start simplifying anything with those number bases, remember you have negative exponents. And since we have this already set up as a fraction, remember this means that we would actually be on different floors of the fraction. So that means this quantity of -3 to the -3rd has to be in the denominator. So I'm going to keep my base of -3, but I'm going to make it into a positive exponent. Then this y to the -3rd, I'm going to move it to the numerator, but make it a positive exponent. So this would become y to the 3rd power. And then to finally simplify your answer, make sure you do this with parentheses. And then make sure you have your exponent on the outside of the set of parentheses. And you would get -27. So the final answer for that example would be y to the 3rd over -27. Okay, so let's practice a couple. Again, I want you to pause your video and I want you to see how you do with these ones. Then we're going to check in and see how you did. Then there'll be a couple for you guys to try out on your own. All right, so let's see how you did. On this one, you would want to keep your base, subtract your exponents in order. So 6 minus 9 would give you -3. Put it over 1 and flip it. So this would be 1 over 7 to the 3rd power. And we're going to have to figure out what 7 to the 3rd power is, which would be 343. So your first example is 1 over 343. For question number 2, first thing, simplify your numerator. So that would give you, keeping your base and adding your exponents together, 6 to the 8th over 6 to the 9th. So I'm going to keep my base and subtract my exponents together. So I would get 6 to the -1, put it over 1, and flip it to make it 1 over 6 to the 1st power, which would end up being 1 over 6 for your answer for question number 2. Now for question number 3, I'm actually going to put this on a different slide to make sure I don't run out of space. But a hint to get you started on that one is you want to make sure that you put actually make a fraction out of the x to the 2nd. So you better put a 1 underneath that one so you know exactly what you would need to do. Okay, so if I start multiplying straight across, I would end up with 2x to the second over x to the fourth, because x to the fourth times 1 would just be x to the fourth. You can see that you have a set of x's, and I would be dividing with the same base, so that means I would keep the base, subtract the exponents, so 2 minus 4 would give me negative 2. I'm going to keep the 2 in the front. Now the next thing I need to do is fix that negative exponent. So I'm going to take that x to the negative 2 and move it to the denominator. So again, I'm going to keep the 2 over 1, but I'm going to flip that x to the negative 2 to make that 1 over x to the second. Okay, my next move, multiplying straight across. So 2 times 1 is 2, and 1 times x to the second is going to be x to the second power. So your final answer for question 3 is 2 over x to the second power. Okay, for question number 4, hopefully you got that one. What you're going to do is you're going to take that power of 3 and raise it both to the numerator and denominator. So that's 1 to the third over 4 to the third. 3 copies of 1 is just 1, but 4 copies of 3, or 3 copies of 4, sorry, is 64. So final answer on question number 4 is 1 over 64. Okay, and for number 5, you're going to distribute that negative 4 to both the numerator and the denominator. So that would be 3 to the negative 4 over 2 to the negative 4. Again, we're on both different 4s, so we have to move that 3 to the denominator and make it a positive exponent. And you have to move the 2 from the denominator up to the numerator and make it a positive exponent. To start simplifying, we have 2 to the 4th power, which is 16, over 3 to the 4th power, which is 81. And you always want to check your fraction and see if it doesn't simplify. So 16 over 81, and that will give us the same thing back. So 16 over 81 would be the final answer. Okay, and then finally, just to see where you're at with this, and these ones you'll be typing into Edpuzzle to see where you're at, to make sure you understand your rules. You're going to, again, keep your base and subtract your exponents. And then with this one, remember, make sure you're distributing your factor to each on both the numerator and denominator. So guys, on that first one, the final answer is going to be a to the 4th over 3, because when you keep your base and you subtract your exponents, after you simplify the 3 over 9 to 1/3, you get a to the 4th and b to the 0. Remember, b to the 0, anything raised to the 0 power would just give you 1. If I put anything over 1, and then you're going to multiply everything across, 1 times a to the 4th is just a to the 4th, and 3 times 1 is 3, so your final answer would be a to the 4th over 3. For question number 2, 2 to the negative 2, x to the negative 2, and then y to the second raised to the negative 2. Well, on the bottom, you're going to be multiplying those together because you have a power of a power. So that would turn into y to the negative 4. But I'm noticing we have negative exponents everywhere on that problem. So that means we're going to have to flip things around. So 2 to the negative 2 goes to the denominator. X to the negative 2 goes to the denominator. And then finally, y to the negative 4 goes to the numerator. And then as a last step, make sure you simplify 2 to the second power, which is 4. So your final answer for question number 2 is y to the 4th over 4x to the second power.